Okay, in this video, we're going to talk about a huge topic here, factoring. Really, really important to know how to factor as you go into calculus. And many of you have, I'm sure, learned this before, but as I was writing notes for this, I realized there's actually quite a lot to talk about when it comes to factoring. So what is factoring? Factoring is really just making a polynomial, turning a polynomial into a product, turning a polynomial into a product. Multiplication. So for example, we've been talking about polynomials. X to the 6th plus 3x to the 4th in factored form would look like this: x to the 4th times x squared plus 3. Convince yourself if you distribute that, right, multiply it back out, that's going to give you x to the 6th and then plus 3x to the 4th. Here we have a degree 2 quadratic trinomial, and that factors in factored form. It can be shown that this is the product of x plus 6 times x minus 2. You can multiply that out and convince yourself that you get this when you simplify it and combine the like terms. 2x squared minus x minus 10 in factored form. 2x minus 5 times x plus 2. Again, you could multiply that out. And what sometimes feels weird is even this little tiny polynomial, x cubed plus 8, when you write it in factored form, looks like this. So the challenge is, we know how to multiply this out and get to the polynomial. The challenge is getting from the polynomial into the factored form. So there's a few techniques for doing that, and that's what we're going to talk about. So first, most basic type of factoring is just taking out what we call the greatest common factor. So for example, if I was factoring 2x to the 7th plus 6x cubed, I'm looking at those two terms. I'll start with the numbers. Between 2 and 6, both of those terms of factors, have at least a 2 in them, right? 6 is 2 times 3. So I know I can take out a 2. And then I look at my x's. I have x to the 7th and x to the 3rd, which means both of those have at least x to the 3rd. So I factor out 2x to the 3rd. And then thinking about, if I factor that out from 2x to the 7th, what would be left would be just x to the 4th. Why? Well, you could convince yourself if you multiply this back in, remember we're going to add those exponents, that would get me to x to the 7th. But I'm also going to have, if I pull out 2x to the 3rd from 6x to the 3rd, I've taken out all of my x's, but I need a plus 3 so that when I multiply this back in, I get my 6. So this would be the factored form here. You might pause the video now and try pulling out the greatest common factor from these three terms. All right, so now we'll look at this. I always start with the numbers 15, 6, and 9. If I think about what multiplying factor is in all three of those numbers, definitely 3, right? Each one of those numbers is divisible by 3. Is terms of x's, x to the 9th, x to the 7th, x squared. Everybody has at least 2 powers of x, so I can factor out 3x squared. Now I'm pulling out 3x squared from 3 things, so sometimes it helps to kind of remind yourself that there should be 3 spots here to put things. And so for the first one, I want to think, what would I multiply 3x squared by to get back to 15x to the 9th? I'm going to need a 5 for the 15, and in terms of x's, I'm going to need x to the 7th, so that adds up to 9. For 6, for the 3, I'm going to need a 2. To get from x squared to x to the 7th, I'm going to need to multiply that by x to the 5th. And then finally, for the 9x squared, I'm going to need just a 3 because I pulled out all of my x squareds. So this would be the factored form. So that's pulling out the greatest common factor. And then we can look at trinomials. And this type of factoring is maybe the one you're most familiar with. Back on that first page, this is kind of that idea that x squared plus 4x minus 12 factored into x plus 6 times x minus 2, which were two binomials. And so anytime you have a trinomial that's a quadratic, if it factors, we would think that it's probably going to be just two binomials multiplied together. And if you just think logically in terms of like how we multiply, if the first term is going to be x squared, the first two terms multiplied together, the only way to make that happen would be if both of those were x. Now, for the last two terms, knowing how we multiply, the last two terms have to multiply to get me to positive 16. And there's lots of ways I can do that. If I think about numbers that multiply to positive 16, I want 1 times 16 works, 2 times 8 works, 4 times 4 works. These are numbers that multiply to 16. But I'm only going to choose one of them because I have to also realize that when I multiply the outer and the inner, I have to get 10x. And so the only way that's going to happen is if I choose the two numbers that multiply to 16 that add to 10. So in this case, I'm going to choose the 2 and the 8 because that adds to 10. And let's just convince ourselves that this is correct. If we multiply this out, x times x is x squared, x times 8 is 8x, this is 2x, and then the 2 times the 8 gives me 16. If I combine my like terms, there we go. Okay, so for this kind of factoring, then the idea is you want to find, once you know it has to start with x and x, but then to get the rest of it, what you want to try to do is find two numbers. Here, I'll write it right here. We're choosing the 2 and 8 because I need two numbers that multiply to, in this case, 16, but add to 10, my middle term coefficient. That's how we're going to choose the numbers. All right, so you might pause the video and try this next one here. Okay, using the same idea here, first two terms have to be x. So now what I want to, this is kind of what I'm thinking now. I'm looking at the negative 8 and the positive 15. So I want two numbers that multiply to positive 15 and add to negative 8. That's what I'm looking for when I'm factoring here. So if you think about it, 15, if it's going to add to negative 8, then I have to be thinking about negative numbers, and negative 3 times negative 5 multiplies to positive 15, but adds to negative 8. So it's going to be minus 3 minus 5. Again, for these next two, if you want to, you can pause the video. It's probably a good idea. See if you can get those factored and then check your answer. All right, for this first one, it starts with just x squared. It's got to be x and x. Now I'm just going to say it. I won't write it. I want two numbers that multiply to negative 21, but add to 3. So what I'm thinking is 7. I'm sorry, make that a 4x. Goodness. Let's make that a 4x. So sorry if you pause the video. That wasn't going to factor the way I had written it. So I'm thinking of 7 and 3. And if I'm going to get a positive 4x, this should be positive 7 and minus 3. So x plus 7, x minus 3. Yes, if you paused the video and got stuck for a while, that was a good reason. I accidentally wrote down the wrong polynomial there. That's okay. We'll work with it. But maybe it's a good reminder too, though, that not everything is going to factor. So if I had, maybe I'll make a more obvious example. If I had x squared plus 2x plus 7. And I know there's no numbers that, the only numbers that multiply to 7 are 1 and 7 and or -1 and -7, but none of those add to 2. Then we just say this doesn't factor. You just have to leave it. So maybe that was a good mistake. Just to remind you that not all trinomials have to factor. Okay, so x squared minus 4x minus 45. So it's got to be x and x, two numbers that multiply to -45. So I got to start thinking about the products, numbers that multiply to 45. 1 and 45, 3 and 15, 5 and 9. And I'm noticing that 5 and 9 could have a difference of -4 if I make the negative on the 9. 9, and that multiplies to -45. So I would have x minus 9, x plus 5. By the way, the order of multiplication doesn't matter. So if you wrote x plus 5, x minus 9, that is correct as well. It's the same thing. Okay. Now, something like x squared minus 16 is not a trinomial. And we can think of it as a different type of factoring. Some people know this as a difference of squares. But I want to show you, you really can think of it the same way if you think of, in this case, well, here's what I'd be thinking of. Isn't this the same as x squared plus 0x minus 16? In which case, what I would be thinking of is two numbers that multiply to -16 but add to 0. And if you think of it that way, it would have to be 4 and -4. They multiply to -16 but add to 0. Now, you don't have to think of it that way, of course, but just to be consistent, it does work with how we were thinking of it. But this is kind of a common thing to be factored. And after you do a bunch of them, you start to realize, for example, if I did x squared minus 9, that's going to factor into x plus 3, x minus 3. And this is also known as a difference of squares. 9 is a perfect square. 16 is a perfect square, right? 4 times 4, 3 times 3. And so anytime you have something that has the form of a squared minus b squared, it will always factor into a plus b times a minus b. So if you know that, that's fine too. This is also a difference of squares, 25 minus x squared. 25 is 5 squared, that's a perfect square. But notice it's backwards, and so you cannot change. A very common mistake is to change this to x squared minus 25 and use this idea or this idea and just say it's x plus 5 times x minus 5. But this is not the same as that. The order of subtraction matters. But it's very simple if you just flip these around. 25 minus x squared would factor into 5 plus x times 5 minus x. And you might say, well, Grant, isn't 5 plus x the same as x plus 5? Because the order of addition doesn't matter. You'd be right. But 5 minus x is not the same as x minus 5. If you're wondering why, pick a value for x. For example, if x was 7, 5 minus 7 is -2, but 7 minus 5 is +2. These two terms are not the same. So this is a separate problem, but it's not the same as this one. Okay, so those are easy to spot. Difference of squares are nice, easy things to factor. I do want to remind you that this would be known as a sum of squares. X squared plus 9 is x squared plus 3 squared, and that does not factor. You can't, it has to be a difference. It has to be a subtraction. This does not factor. So there's no such thing as, well, there is such thing as a sum of squares, but they just don't factor. I'll put sum of squares. And you can use this idea. This is not a quadratic. This is a degree 4 polynomial. But whenever you see like something minus, especially if this is a perfect square, you can still sort of think of it as a difference of squares. The only difference here would be the two things that multiply to give me x to the 4th. I'd want to have x squared and x squared. And that would be x squared plus 7 times x squared minus 7, just like a difference of squares. Now, you could go further if you wanted to. This is a sum of squares, just like this one, so this doesn't factor. Some people would say x squared minus 7 doesn't factor. I would disagree. I would say if you really want to force it to factor, it would be x plus the square root of 7 times x minus the square root of 7. However, most of the time, if this doesn't factor into a nice square root, like the square root of 9 is 3, the square root of 16 is 4, this is fine if you want to, but typically we would just leave it right here and not take it because it just gets messier. And using the same idea, now this is not a difference of squares because we're back to 3 terms, but even though it's a degree 4, just to show you that you could still factor it like a trinomial as we were doing before. But again, the same idea, you'd want to make this x squared and x squared. And you'd want to be thinking of factors of 9 that add to negative 10. So the only way that's going to happen is if you use minus 1, minus 9. Check the middle terms. Minus 9x squared minus 1x squared gives you the minus 10x squared. And then now this you could go further because each one of these is a difference of squares. Whoops, not x squared. It would be x plus 1, x minus 1, x squared minus 9 factors into x plus 3 times x minus 3. So if you can take it all the way down to linear factors, that would be preferable. Okay. Now, factoring when we've been factoring things that have the form of x squared plus some number x plus c, but if you put a number in front of that, if I make it ax squared plus bx plus c, and a is not 1, in other words, something like this, your coefficient of x squared is not 1, some of you may remember that the factoring gets a little bit trickier. Now, I have my opinion on this, and this is based off, there are lots and lots of students. Many of you I have learned a technique, a recipe, a cookbook recipe for how to factor something when this number is not 1. I've seen 3 or 4 slightly different techniques. But here's been my experience. When I get something like this, I'll have a student say, oh, yes, 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 I remember this technique for factoring it. Now, okay, great. Well, tell me what it is. Well, I forgot. And so my goal as a teacher is I want to try to give you the tools you can get through a problem if you forget the recipe. I forget the formula. You should not be helpless if you don't remember a formula. At least that's my goal as a math teacher. I want you to be able to get through this. So I don't have fancy techniques for these. It's kind of old-fashioned, but to factor something like this, I use plain old guess and check. And that sounds kind of tedious, but I have some strategies that I want to share with you that make this hopefully a little more enticing, rather than trying to memorize some technique that you're going to forget in a year. Because here's what I know. If I assume it factors into a binomial, then I know the first 2 terms have to multiply to give me 5x squared. Well, only way to do that is if it's 5x and x. And I know the last 2 terms have to multiply to give me 6, but I'm no longer thinking of factors of 6 that add to negative 17. Why? Because whatever number I put here, if I were to multiply it out, I'm going to multiply it by 5, right? So instead, I'm just thinking about the factors of 6. Now, if they multiply to positive 6, but this is going to be negative, then I have to be thinking of negative numbers. So I'd be thinking like negative 1 and negative 6. That multiplies to positive 6. And maybe negative 2 and negative 3. Okay. So what I mean by trial and error is if you went with the negative 1 and the negative 6, you might try going minus 1 here, minus 6. Now, the only thing you really need to check, we know that's 5x squared, we know that multiplies to positive 6. I just need to make sure I get negative 6, negative 17x in the middle. And that would come from this times this and this times this. But what do I have? I have negative 30x and negative 1x. There's no way I'm going to get negative 17, right? So then maybe I try it the other way. Maybe I go minus 6 here x minus 1. What do I have there? That's minus 5x. Minus 6x would get me minus 11x. That's not going to do it. So what that's telling me is it's not going to come from these two factors if this thing's going to factor. So let's move down to the minus 2 and the minus 3. If I put the minus 2 there and the minus 3 there, check my middle terms. That's minus 15x minus 2x, and that actually does add to minus 17, so I've got it. The only other option I would have had was flipping these, right? So luckily I got it on the third attempt here. Okay, so that's, now I always leave it open. If you remember a fancy technique for factoring like something like this and you remember it and you're going to remember it forever, by all means. I'm not out to change anybody. I'm just here to provide ideas for what to do when you get stuck, which will inevitably happen. You're not going to be able to memorize everything as you go forward. Now, oftentimes I'll get a lot of pushback when it's something like this, because makes this one a little bit harder, I still have 6 as my last number, is the first terms have to multiply to give me 4x squared. And there's two ways that could happen. It could be 4x and x, or I could have 2x and 2x, right? Both of those would have to multiply. Both of those could give me the 4x squared. So I have to consider two cases there. And I have to think about the last terms multiplying to give me -6. That means I have to have opposite signs, which means I could have plus or minus 1 and plus or minus 6, plus or minus 2, plus or minus 3. So that's a lot of things to consider. And this is where a lot of times students will say, Grant, I get it, but there's too many things. I don't really like guess and check here. But here's my response. What if I told you I can already tell that this is not a possibility? It is not going to factor into 2x and 2x. How do I know that? Let me explain that first, and then we'll factor it. If it was 2x and 2x, put that back up there. Let's try the 1 and the 6. I don't know if it's plus or minus yet, but let's say I do. Let's say I go minus here, plus there. The reason I know that this doesn't factor is this factor right here, going back to how we started, has a common factor of 2, which means I should be able to take a 2 out of that, right? 2 times x plus 3, and then this would be 2x minus 1. But here's why I know that can't work. If I can take out a 2 in the factored form, it means I should have been able to take out a 2 here. And notice there is no way you can take out a 2 there, so there shouldn't be a way to take out a 2 when you factor it. I know that can't happen. So now let's use that argument. So that means the 6 can't go there. Obviously, it can't go there because I run into the same issue. If I move to the 2 and the 3, the 2 would have to go somewhere, right? If I put the 2 there and the 3 there, I'm going to have a common factor of 2. So I know if this thing factors, it cannot start with 2x and 2x. It has to be 4x and x. And then here's the next thing. If I start going through some examples here, like say, for example, I go with the plus or minus 1 and the 6. The 6 cannot go here, because if I put the 6 here, I want to do it kind of lightly. If I put the 6 there, whether I put plus or minus, notice there's a common factor of 2 again. And there is not a common factor for every single term here. So if 6 was going to be an option, it would have to go here. And that means the 1 has to go here. And then here's what I do next. I haven't even assigned signs, but what I know I would be generating here is that would be a 24x and that would be a 1x. And there's no way I'm going to get 5x whether I put plus or minus. So then that tells me the 1 and the 6, there's no way. Well, no, we said the 6 can't go there. So I know it can't be this, which means it has to be those two factors. Let me start down here. And then using that same idea, if I use the 2 and the 3, where does the 2 have to go? If it's going to work, it can't go here. The 2 and the 4 would have a common factor, so it's going to have to go there. The 3 is going to have to go there. let's see what we have for our middle terms. We have an 8x and a 3x. If I want to get a positive 5x, the negative, this should be 8x minus 3x. So I should make that plus. And you can see that that works. Multiply it out. So this is the idea of ruling out possibilities for that last number based on common factors. This might be early, but let me show you my reasoning one more time, and then I'll give you one to practice here. So if I have 8x squared minus 11x minus 10, what are my options? It could either factor into 8x and x to give me 8x squared, or it could be 4x and 2x. The last numbers have to multiply to negative 10, and so that would be either plus or minus 1, plus or minus 10, or plus or minus 2, plus or minus 5. So if you starting to pick up on this idea, once again, let's go to this one right here. 4 and 2 are both even numbers, and notice if I used 1 and 10, or 10 and 1, or 2 and 5, or 5 and 2, one of these factors is going to get paired with an even number as well, right? If I put the 10 there, I have a common factor of 2. If I put it there, I have a common factor of 2. For the 2x plus 5, if I put the 2 there, I have a common factor of 2. If I put it there, I have a common factor of 2. So I can already tell that's not going to work. So if it's going to be factor, it has to be 8x and x. More strategy for factoring, I guess, trying to get there the fastest way. When I look at that middle term, if it's not too big of a number, then I usually start with the factors that are closer together. Why? Because, if it's a big, like you can imagine, if I put a 10 here, 8 times 10 would be 8. If I had a really big number there, then it's probably going to be generated with the 10. But if it's not a big number, then it's probably using the factors closer together. So I have 2 and 5. I know if I was going to factor it, the 2 cannot go with the 8, because that's a common factor of 2. So it's going to have to go there. 5 goes there. What do we have? We have 16x. We have 5x. To get negative 11x, I'm going to want this to be negative. So I'm going to put the minus there, the plus there. That's how it factors. And see, you have to agree, that wasn't too bad. If you can rule out a bunch of cases, then it really wasn't that bad. Okay, I recommend now for this next one, pause the video, see if you can get that to factor. All right, so then what could we have here? It could be 6x and x, or it could be to multiply to 6x squared I'm going with. So 2x and 3x. If it was going to multiply to negative 12, the last two numbers, it's plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. Okay. Using kind of the similar idea that if this middle number is not really big, then in this case, I probably am going to be using the 2x and the 3x so that I don't get too big of a number. So I would probably start my guessing there. Likewise, I can see that if I use a 12 and a 1, I'm probably not going to get just a 1x there. So now, what do you know about this factor? 2 and 6. Both of those are even numbers. So if you were to use the 2 and the 6, the 2 or the 6 would have to go with the 2. That would be a common factor. And the same thing up here, right? If you put a 2 or a 6 there, you're going to have a common factor. So it's a definitely not going to be, if it factors, it's not going to be, the last numbers aren't going to be 2 and 6 for either case here. Okay. So you could you go with the 2x and the 3x. Okay. Where if I was using 3 and 4, well, you can see there's a problem both ways. I can't put the 3 there, right? Because I have a common factor of 3. And I can't put the 4 there because I have a common factor of 4. So if it was going to work, the only way it would work is if the 4 goes there and the 3 goes there. So I'm using this case right here. And sure enough, there's 8x, there's 9x. To get a positive x, I want this one to be negative. Negative 8x plus 9x gives me positive 1. So this will be minus, this will be plus. And even if you started with the 6x and the x before you went here, I think you would have ruled out things pretty quickly and gotten to that. Now, I still will have students like, okay, I kind of get that, but I'm going to stick with my handy dandy recipe for factoring something like this. And the most common way, by the way, to factor something like this, I think they call it the A times C method. You multiply these two together, and then you work with that number. You do some factoring grouping. My response to that would still be, you're going to run into problems sometimes because you had a quadratic like this. If you multiplied 100 times 17, you got 1700, and then you're trying to figure out factors of 1700 that add to negative 180. That's going to be a chore. Whereas if you just gave it an honest like attempt before you jumped into something like that, I mean, there's more than one way to get 100x squared, but if you go with maybe the obvious, maybe 10x and 10x, of course, it could be 100x and x and 20x and then, there's only so many numbers that add to 17 here that multiply to 17, namely 1 and 17, right? But and if this is negative, that means they're both going to have to be minus. So if you tried minus 1 minus 17, notice that 10 times negative 17 is negative 170. There's negative 10, and that's going to add up to the negative 180x. So I've got it. Another idea with factoring, and this is particularly useful if you're factoring something that has 4 terms, like a cubic equation, and call it factoring by grouping. And the name kind of speaks for itself. We're going to group some terms together. So if I have x cubed plus 3x squared plus 4x plus 12, I'm going to group the first 2 terms and the last 2 terms. And then what I'm going to do is factor out individually, taking out the greatest common factor between x cubed and 3x squared. I'm going to go this way. I can take out an x squared. And if I take that out from here, I'm going to be left with x plus 3. And here, 4x plus 12, I can take out a 4, and that will also leave me with x plus 3. And then the idea is there's really only 2 terms now. That's 1 term and that's 1 term. What's common to both of those is x plus 3. So I take out an x plus 3, and if I take that out from this term right here, I'm going to be left with x squared. And if I take that out from this term here, I'm going to be left with plus 4. X squared plus 4, that would be another sum of squares we talked about earlier. That doesn't break down anymore, doesn't factor, so you'd be done right here. Try that for the next one. So maybe pause the video and see if you can group the terms. It's a little bit tricky. Watch out for the negatives. Okay, so I'm going to factor and group, but I'm going to rewrite this because there's a little bit. I want to group those 2 terms, and then this minus, here's the trick. I'm going to pull that minus out, but if I then group the next 2 terms, it's going to be 4x minus 20, right? If I take out that minus, I'm grouping these terms, so I have to separate it with parentheses, and there would have to be a negative there so that when I distribute that back in, that's a plus 20. Got to watch out for that. From this term, I can take out an x squared, using with x minus 5. From this term, I can take out a 4, which also leaves you with x minus 5. See, this technique relies on the fact that you get a common factor when you do that, because then I can take out x minus 5 and be left with, from here, x squared, from here, minus 4. And that actually is a difference of squares. So factoring that completely, it's x plus 5 times x plus 2 times x minus 2. Okay. One more thing to talk about. And this is what's known as a sum or difference of cubes. There's a difference of squares formula we talked about, and there happens to be a difference of cubes and a sum of cubes formula. And some of you may remember that, and some of you may not remember, may remember learning it, but it's not always something that you would keep in our memory very often. So you know my idea. I want to try to show you how you can get through this without relying on the formula. I will, for this one, give you the formula at the end, but I want you to see how you could do this. As long as you know, so we call it a difference of cubes because 8 is 2 cubed, right? This is the same as x cubed minus 2 cubed. And if we start, the first factor is going to be x minus 2. Okay. So it's just going to be, if it's x cubed minus 2 cubed, it has to be x minus 2. And there's a reason for that. We can get into that in class if we want to. But now let's think, okay, there's going to be more there, and I'm just going to think backwards. What I have to be able to multiply whatever I put here out and get back to x cubed minus 8. So what would have to go here? What would I multiply x by to get me to x cubed? It's going to have to be x cubed. I also have to multiply -2 by something to get -8. So what would that have to be? That's going to have to be +4. -2 times +4 gives me -8. Now you notice I left some room there, and that's because there has to be another term. Whoops, I'm sorry, this should have been an x squared. I'm not sure how I said that, but x times x squared gets me x cubed. Yes, I probably said that and wrote x cubed. Here's why I know there has to be something there. With what I have written down so far, if I were to multiply this out, notice that that's going to give me a -2x squared. And there isn't a negative of 2x squared here, right? In the final product. What that means is somewhere I have to generate a positive 2x squared so that this would cancel out. And that's going to come from multiplying x. See, I want, whatever I put here, I want this to be positive 2x squared, so those cancel out. So if you think about it, what would x have to be multiplied to make that happen? It's going to have to be x squared. It's going to have to be 2x. Okay. Now there is, how do I know I'm done? If you multiply this out, that was the previous homework. If you multiply this all out, you're going to see a bunch of stuff cancel, and you are going to end up with x cubed minus 8. That's how it factors. And generally speaking, a sum and a difference of cubes does factor into a linear term and then a quadratic term. And notably, this quadratic term usually doesn't factor. Doesn't factor anymore. You can probably see why. There's no numbers that multiply to 4 that add to 2, so it's not going to factor. Let's try one more difference of cubes. I'll throw in another example just so we get the idea of this. So let's say I had x cubed minus 125, which is really x cubed minus 5 cubed. 125 is 5 cubed. So this is going to be x minus 5. Okay, the last term is going to have 3 terms. Just like we did for the other one, there has to be an x squared here, so that gives me x cubed. There has to be -5 times +25 gives me -125. And there has to be a middle term, and how I figure out what should go there is just like the last one. If I multiply these out, that gives me -5x squared. So that means I have to generate a positive 5x squared, which is going to come from multiplying x times positive 5x. That's it. And then this is known as a sum of cubes. A sum of cubes because 1,000 is 10 cubed. And if I told you that the first factor was just like for difference of cubes, x plus 10, and the rest of it was a trinomial, I'll bet you could figure it out, what should go there. So maybe pause the video and see if you can figure out how to factor that last part. Okay, x would have to be multiplied by x squared. 10 to get to 1,000, there has to be 100. Strategy then, look at that. This time this gives me positive 10x squared, which there isn't over here. So I need to generate a -10x squared, which is going to come from multiplying x by negative 10x. That's the final factor. Okay, I promised I'd give you, so if you're a formula person, what we're basically saying is x cubed minus a cubed will factor into x minus a times x squared plus ax plus a squared. And x cubed plus a cubed, the sum of cubes is x plus a times x squared minus ax plus a squared. So if you're good at memorizing things, by all means, but I'm hoping to give you, you have a way, if your memory fails you, you can still figure out how it factors. All right, that's it for now. Thanks for watching. Let me know if you have any questions.